So in this question, we are told that it requires 1.5 seconds for a freely falling object to travel the last 30 meters before it hits the ground. Now we've drawn a little picture over here, and what we've just highlighted would correspond to this section of the picture right here. And what we want to do is affix some labels to this drawing. So for example, where the object is located here would be its initial position. We're going to call that y0, and that's going to equal 30 meters because it's 30 meters above the ground. And then when the object hits the ground, the final y coordinate y would equal 0 meters. Now we know that it takes a time interval of 1.5 seconds for this to take place, and then the acceleration of this freely falling object in the y direction would be negative 9.8 meters per second squared. In part A, we want to find the velocity of the object when it is 30 meters above the ground. So in this case, we want the velocity at this location. We've labeled that the initial location. So for the purposes of part A, we are looking for the initial velocity of the object. Let's turn to one of our equations from one-dimensional kinematics. And here is that equation. We have this delta y. Recall that delta y can be expanded into the final y coordinate minus the initial y coordinate. And then at this stage, it would be a matter of just plugging in the known data. So the final y coordinate was 0. The initial y coordinate was 30. We are looking for this initial velocity for this portion of the object's journey multiplied by the 1.5 seconds. And then we have plus 1/2 multiplied by negative 9.8 multiplied by that time interval. Again, 1.5 seconds. Don't forget to square that. So the left side will simplify to negative 30. On the right side, we can pick up our calculator and simplify this term here and end up with that result. Let us then add to both sides that 11.025. This gives us about negative 18.975 is equal to 1.5 times the initial velocity, and then just divide both sides of this equation by 1.5. And when we do so, we end up with approximately negative 12.7 meters per second is equal to that initial velocity. So this is the correct answer to part A. This is how fast, or the velocity I should say, with which the object is falling at 30 meters above the ground. Now let's go back up and see what part B is asking for. It says, find the total distance the object travels during the fall. Now we already know that it travels 30 meters for that yellow portion of its journey. What we need to do is figure out how far it has fallen for this part of its journey. And then once we have that, of course, we can just add that to the 30 meters that it fell for the second part of its journey. So let's list some known parameters for that blue section of the journey. Now the object was released from rest. So for the blue section of the journey, we know that the initial velocity would equal 0 meters per second. We still know that the acceleration is the negative 9.8 meters per second squared because it's in free fall. Now this is neat because at this location right here, we just figured out the velocity. For the blue section of the journey, that would be the final velocity. So we know that that is that negative 12.7 meters per second that we just figured out. And now we can use a different equation from kinematics to figure out how far the object has fallen during that blue segment of the journey. So let's take a look at that equation. And so this is a different equation, but it's going to allow us to find the delta y. We can go ahead and plug in the known values that we just enumerated earlier. On the right-hand side, this is 0 squared, so of course that's just 0. Let's square the left side. And then let's multiply this 2 times negative 9.8. And then at this stage, very easy, we can solve for delta y by dividing both sides of the equation by the negative 19.6. And when we do so, we get negative 8.23 meters approximately is the delta y. So that's the distance the object fell for the first part of its journey. Let's not forget that the total distance would be that plus the negative 30 meters that it had fallen for the second part of the journey. So basically, we can say that the delta y total is going to equal the distance of 8.23 meters we just determined, plus the extra 30 meters it fell. This is going to give us 38.23 meters. This would be the total distance that the object fell during its journey. Thanks for taking the time to watch the video. If you're interested in making a small donation to my cause, I would greatly appreciate it. Of course, please do not feel obligated to do so. I appreciate you taking the time to watch regardless.